एम्पियर इज फ्लोइंग इन अ वायर ऑफ लेंथ 1.5 मीटर. आता बघा काय दिलेलं आहे, एक करंट दिला आहे, सॉरी एक कंडक्टर दिला आहे, वायर दिलेली आहे, त्याच्यातून 10 एम्पियर करंट पास आउट होते आणि त्याची लेंथ दिली आहे 1.5 मीटर. नाउ द फोर्स ऑफ 15 न्यूटन ॲक्ट्स ऑन इट व्हेन इट इज प्लेस इन अ युनिफॉर्म मॅग्नेटिक फील्ड ऑफ 2 टेस्ला. ठीक आहे, मग 2 टेस्ला 2 टेस्ला एवढं मॅग्नेटिक फील्ड असताना त्या वायरवरती 15 न्यूटन एवढा फोर्स ॲक्ट होते. Now the angle between the magnetic field and the direction of the current is how much? Here we find out the angle in between the magnetic field, direction of the magnetic field and direction of the current. Now we know that the force experienced by the conductor in a magnetic field is F is equal to ILB sin theta, right? This is the force experienced by the conductor in a magnetic field B, right? Now how much is the theta here? We have to find out the sin theta and then we get the theta. Here F is equal to how much? F is equal to 15 Newton. Here we get 15 Newton is equal to I is equal to how much? Current is 10 ampere. We get 10 into length of the conductor is 1.5, magnetic field here 2 Tesla, we get 2 into sin theta. Here we solve this simple MCQ, we get sin theta is equal to 15 upon 10 into 1.5 into 2, right? But here 10 into 1.5 is 15, but therefore here 15 and 15 get cancelled. Here we get sin theta is equal to half, and we know that the theta is equal to what? 30, because sin 30 is half. So the angle theta is equal to 30 degree. So the answer is first A, 30 degree. This is the correct answer, right? This is the one of the simple MCQ based on the force acting on a straight conductor in a magnetic field, right? The cyclotron motion. Now what is the cyclotron motion? मग आपण जस्ट आता स्टडी केलं, जर चार्ज मॅग्नेटिक फील्डमध्ये मोशनमध्ये असेल तर त्याच्यावरती काय होतं आहे, तर मॅग्नेटिक फोर्स ॲक्ट होते. नाउ हियर वी कन्सिडर द चार्ज पार्टिकल मूविंग इन अ एक्सटर्नल मॅग्नेटिक फील्ड. नाउ हियर वी कन्सिडर द डायरेक्शन ऑफ मॅग्नेटिक फील्ड इज इन इनवर्ड डायरेक्शन. डायरेक्शन ऑफ द मॅग्नेटिक फील्ड इज व्हॉट? दिस इज इन इनवर्ड डायरेक्शन. हियर द डायरेक्शन ऑफ दॅट मॅग्नेटिक फील्ड इज इन इनवर्ड डायरेक्शन. म्हणजे टोटल या प्लेनमध्ये मॅग्नेटिक फील्डची डायरेक्शन कशी दाखवली आहे, तर ती इनवर्ड डायरेक्शनला दाखवलेली आहे आणि ह्या प्लेनला कशी असेल, परपेंडिक्युलर असेल. सपोज चार्ज इज मूविंग थ्रू दिस एक्सटर्नल मॅग्नेटिक फील्ड. आता मॅग्नेटिक फील्डमध्ये हा जर चार्ज मूव होत असेल तर त्याच्यावर काय होत असतो, तर फोर्स ॲक्ट होत असतो. त्या फोर्सला आपण म्हटलं होतं मॅग्नेटिक फोर्स. नाउ हियर दिस इज द डायरेक्शन ऑफ दी फोर्स, दिस इज द डायरेक्शन ऑफ द वेलोसिटी ऑफ दॅट चार्ज. मतलब चार्जची जी काय वेलोसिटी असेल ती या डायरेक्शनने असणार आहे आणि मॅग्नेटिक फील्डची डायरेक्शन काय आहे, तर इनवर्ड डायरेक्शनला असणार आहे. तर मग ह्या चार्जवरती जो काय फोर्स ॲक्ट होईल तो फोर्स कोणत्या डायरेक्शनला असेल आणि किती असेल तो. यू नो दॅट अकॉर्डिंग टू द मॅग्नेटिक फोर्स, दिस मॅग्नेटिक फोर्स FM इज इक्वल टू Q इन ब्रॅकेट VB sin theta. ठीक आहे, दिस इज द फोर्स ॲक्टिंग ऑन दी चार्ज. मग इन दिस सिच्युएशन वी नो दॅट व्हेन दिस charge is moving in a magnetic field, then this charge undergoes the circular motion. तो चार्ज काय होत आहे, तर तो सर्क्युलर मोशनमध्ये फिरतो आहे. मग हा चार्ज काय होणार आहे, मॅग्नेटिक फील्डमध्ये मूव्ह होतो आणि या पद्धतीने सर्क्युलर ऑर्बिटमध्ये मूव्ह होते. मग सर्क्युलर ऑर्बिटमध्ये मूव्ह होत असेल तर राईट हँड रूलनुसार त्याच्यावरती फोर्स कसा ॲक्ट होईल. नाउ दॅट मॅग्नेटिक फोर्स इज ॲक्टिंग अलॉंग द रेडियस ऑफ द सर्क्युलर ट्रॅक अँड टुवर्ड्स द सेंटर, राईट. मग तो जो काय फोर्स आहे तो काय आहे, टुवर्ड्स द सेंटर असणार आहे. मग त्या सेंटरला या डायरेक्शनने जर फोर्स ॲक्ट होत असेल तर तो फोर्स कसा असणार आहे बघा, तो आहे अलॉंग द रेडियस अँड टुवर्ड्स द सेंटर. दॅट मीन्स दिस मॅग्नेटिक फोर्स इज रिस्पॉन्सिबल टू मेंटेन और सस्टेन द सर्क्युलर मोशन. दॅट मीन्स इट प्रोवाइड्स द सेंट्रिपेटल फोर्स. दिस मॅग्नेटिक फोर्स प्रोवाइड्स द सेंट्रिपेटल फोर्स. मग हियर वी नो दॅट अँगल बिटवीन वेक्टर V and vector B is 90 degree. Therefore the magnitude of magnetic force becomes FM is equal to QVB, right? This is the magnitude of magnetic force. And how much is the centripetal force? Here V is the velocity and suppose M is the mass of that charge and R is the radius of the circular track. So the centripetal force becomes mv square upon r. Here we equate these two equation. Magnetic force is equal to centripetal force to sustain or to maintain the circular motion, right? Here we equate these two equation. Here we put the magnetic force and centripetal force. What is the magnetic force? Magnetic force is QVB and centripetal force is mv square upon r. Now here v and its square get cancelled. The remaining formula is QBR. Here we get QBR is equal to mv. And you know that mass into velocity is nothing but the momentum. So the formula becomes momentum P is equal to, or mv is equal to QBR, and this is called as the cyclotron formula. In this case we study the cyclotron motion of a charged particle. The motion of that charged particle is circular and its momentum is QBR, right? I hope this is clear. Now next we solve here the MCQ. Here two particles x and y have the equal charge, and after being accelerated through the same potential difference, they enter a region of uniform magnetic field and describe the circular path of radii r1 and r2 respectively. Here the ratio of mass of x to that of mass y is how much? Here we have to find out the suppose masses of these charged particles is suppose m1 and m2. Here we have to find out m1 upon m2 is equal to how much. ठीक आहे, काय फाइंड करायचं या ठिकाणी m1 अपॉन m2 फाइंड करायचं. बघा आता MCQ थोडंसं आपल्याला फसवा आहे. चार्ज पार्टिकल दिलेले आहेत x आणि y, त्यांचं मास आपण मांडले m1 आणि m2. आता ते एक्सेलरेट जे होणार आहे ते एक्सेलरेट कशामुळे होणार आहे? दिस टू चार्ज पार्टिकल्स आर एक्सेलरेटेड बाय दी सेम पोटेंशियल डिफरन्स. हियर वी कन्सिडर द पोटेंशियल डिफरन्स इज सपोज v. पोटेंशियल डिफरन्स किती असेल तर v हा पोटेंशियल डिफरन्स असेल. मग आता एक्सेलरेट होत असेल पोटेंशियल डिफरन्समुळं, तर मग आपण रिलेशन काय घेणार? सायक्लोट्रॉनमध्ये आपण स्टडी केलं होतं सायक्लोट्रॉन मोशनमध्ये. यू नो दॅट अकॉर्डिंग टू सायक्लोट्रॉन मोशन mv that means momentum p is equal to what? QBR, right? This is the cyclotron formula. Here what is the relation in between mass and its radius? Okay, here the relation is m is directly proportional to r, but here in this MCQ these charged particles are accelerated by the potential difference. ठीक आहे, हे पोटेन्शियल डिफरन्समुळे ॲक्सेलरेट होणार आहेत. आणि इथं आपण ॲझम्पशन मांडलं होतं काय, तर ते चार्ज पार्टिकल जो आहे तो सर्क्युलर मोशनमध्ये जर मूव्ह होत असेल मॅग्नेटिक फील्डमुळे, तर त्याचं मोमेंटम इथं घेतलं होतं आपण. ठीक आहे, मग आता ह्या एक्झाम्पलनुसार किंवा ह्या फॉर्म्युल्यानुसार ह्याचा ॲन्सर आपण डायरेक्ट r1 अपॉन r2 लिहू शकत नाही, कारण तो चार्ज पार्टिकल एक्सटर्नल पोटेन्शियल डिफरन्समुळे ॲक्सेलरेट होणार आहे. मग त्याची जी काही कायनेटिक एनर्जी असेल त्याचं आणि ह्या मोमेंटमचं रिलेशन आपल्याला फाइंड करावं लागेल. ठीक आहे, मग व्हॉट इज दी कायनेटिक एनर्जी? यू नो दॅट कायनेटिक एनर्जी इज सपोज E is equal to half mv square. What is here v? V is its linear velocity. Here we multiply and divide by m, we get half m square v square upon m. ठीक है, what is m into v? M into v is the momentum. Therefore here we get half p square upon m. So what is p here? P is equal to what? Here p square is equal to twice m e, and therefore p is equal to taking square root, we get p is equal to under root of twice m e. And we know that the kinetic energy of a charged particle in a external potential, here we get that value is E is equal to ev, right? This is the kinetic energy, right? But therefore here we get this relation for the momentum, right? So here we get momentum p is equal to under root of twice m e is equal to QBR. ठीक है, now by using this formula, what is the relation in between mass and its radius, right? Here E is constant because these two charged particles are accelerated in a same potential difference. ठीक आहे, पोटेन्शियल डिफरन्स सेम आहे म्हणजे त्यांची एनर्जी कायनेटिक एनर्जी सेम असणार आहे. कायनेटिक एनर्जीचा फॉर्म्युला असतो चार्ज पार्टिकलचा E, कॅपिटल E is equal to ev. That means here we get under root of twice m ev is equal to QBR. Here V is same, therefore here we get m is directly proportional to r, that means under root of m is directly proportional to r, here b is constant, but therefore here we get under root of m is proportional to what? R, that means here taking square we get m is directly proportional to r square, right. By using this relation we get m1 upon m2 is equal to r1 square upon r2 square. Therefore, the option number C is correct, r1 upon r2 bracket square. Okay, remember this relation. Now, the next point is torque on current loop. Here we find out the torque acting on a current carrying loop. Now, this loop is kept in a uniform magnetic field. Now, here this uniform magnetic field, this is the radial uniform magnetic field. Now, suppose L1 is the side of this rectangular loop and breadth of this loop is suppose L2. So, how much is the area of this loop? Area of this loop becomes A is equal to L1 L2. Now, here we consider the force acting on the side AB is suppose Fm1 and the force acting on the side CD is suppose Fm2, right. Now, according to right hand rule, we know that the force acting on the side AB, this is the current carrying wire. Here suppose I is the current flowing through this wire, then the force acting on this wire AB is how much? Fm1 is equal to I L1 B sin theta. So, how much is theta here? You know that the side AB and side CD are perpendicular to the direction of magnetic field and BC and AD is along the direction of field. Therefore, for the side AB, theta is equal to 90 degree. Therefore, force becomes I L1B only. Here we get I L1B. This is the force acting on the side AB. Now, how much is the force acting on side CD? Here CD is also perpendicular to the direction of field. Therefore, here we get Fm2 is equal to what? Current into its length L1 and magnetic field is B. But therefore, the force acting on the side CD is also I L1B. That means Fm2 is equal to I L1B sin theta. Here also theta is equal to 90 degree. Therefore, we get the force I L1B. Now, next, how much is the force acting on the side BC and AD? Here BC and side AD is along the direction of field, and we know that suppose conductor is along the direction of field, then the force acting, magnetic force acting on that wire is 0. But after the certain deflection of this loop, the minimum force is acting on the side BC and AD, but their direction is opposite. Therefore, these two forces are cancelled out, right. So, here we consider the only two forces acting on the side AB and CD. Here we know that this according to right hand rule, the force Fm1 and force Fm2 are equal but opposite in direction, right. But here if the force are in opposite in direction, therefore, here torque is exerts on this current carrying loop, because two equal and opposite forces acts on the current carrying loop, right. So, here we know that the formula for the torque is, it is the magnitude of product of magnitude of one of the force and its moment of arm. So, how much is the moment of arm here? Here this current carrying loop is rotating about this central axis, right. But distance of distance from point B to the central axis is suppose L2 upon 2. Here, but the moment arm becomes moment arm is equal to L2 upon 2 into sin theta, right. What is theta here? Theta is the angle between the current loop and the direction of magnetic field, right. So, the torque acting on this loop becomes torque toe dash is equal to magnitude of the force into moment arm L2 upon 2 sin theta plus the another force is Fm2 is equal to Fm2 into L2 upon 2 sin theta. This is the total torque acting on a current loop. Now, we know that here Fm1 is equal to Fm2. Here we put Fm1 and Fm2 is equal to IL1B, and after the addition the formula becomes tau dash is equal to IL1 L2 B sin theta, right. But this is the torque acting on a single current carrying loop. Now here we consider the, suppose this rectangular coil has n number of turns. So the total torque becomes tau is equal to n times tau dash, right. Here we get tau is equal to n I L1 L2 B sin theta. Here L1 into L2 what? It is the area of this current carrying loop. Here we get torque tau is equal to n I A B sin theta, right. But this is the torque acting on a current loop, or the torque exert on a current loop in a uniform magnetic field, right. Now next point. Now next, moving coil galvanometer. We know that the analog voltmeter and ammeter are works on the principle of moving coil galvanometer, right. Now this moving coil galvanometer consists of, this is the current carrying rectangular coil suspended in a external uniform magnetic field. Here the north pole and this is the south pole generate the uniform magnetic field. Suppose here the coil is one end of the coil is connected to the lower suspension spring to generate the counter torque or the counterbalance torque. Now here when current I is flowing through this coil, then the torque is exerts on the coil in a external magnetic field. So the torque exerts on the coil due to the current I and external magnetic field is N I A B, right. This is the torque, or this torque is also called as the magnetic torque on a current loop or the suspended coil, right. Here the this magnetic torque is counterbalanced by the torque generated in a spring, right. Now this torque is nothing but the tau dash is equal to K phi. Here K is called as the restoring force constant and phi is the deflection of that coil. So here we get the torque tau dash is equal to magnetic torque. Therefore here the formula becomes K phi is equal to N I A B. Here phi is equal to what? Phi is equal to N A B divided by K into suppose I. Now here we know that N is the number of turns given to this coil. Now A is the area of the coil and B is the external uniform magnetic field and K is also constant here. But therefore the total bracket is constant. That means here the deflection of the coil is directly proportional to the current flowing through the coil. That means here by using this condition, phi is proportional to the I. By using this condition, here we design the voltmeter and ammeter, right. But the voltmeter and ammeter is designed or the works on the principle of moving coil galvanometer. We solve this MCQ. Here 3 long straight and parallel wires carrying a current are arranged as shown in figure. The force expressed by 10 centimeter length of wire Q is dash dash dash. Here in this figure there are the 3 long parallel conductors, right. But the conductor P, Q and R. Here we find out here we have to find out the force expressed by 10 centimeter length of wire Q. म्हणजे Q वायर वरती किती फोर्स ॲक्ट झाला असेल तो आपल्याला फाइंड करायचा आहे, राइट. मग हियर इनिशियली वी डिसाइड दी डायरेक्शन ऑफ दॅट फोर्स. कारण आपल्या ऑप्शनमध्ये बघा टुवर्ड्स दी राईट म्हणले आणि इथं टुवर्ड्स दी लेफ्ट आणि टुवर्ड्स दी लेफ्ट म्हणले. म्हणजे आपल्याला त्याच्या डायरेक्शनवरून पण डिसाइड करावं लागणार आहे का तो फोर्स कोणत्या डायरेक्शनला असेल आणि त्याची मॅग्निट्यूड काय असणार आहे, ठीक आहे. मग हियर the current flowing through the first wire is in upward direction. Therefore the magnetic field produced by this wire is here in inward direction. That means the conductor Q is in magnetic field and direction of that magnetic field is in inward direction and perpendicular to the conductor or wire. Now similarly here the current flowing through the wire P is in downward direction. Therefore, according to right hand thumb rule, the direction of the magnetic field produced by the wire P here is also in inward direction. That means this is the direction of a magnetic field for the conductor Q. Now, here the current, suppose 10 ampere is flowing through this conductor and magnetic field is in inward direction. Therefore, according to right hand rule, the direction of force is here in towards the right. This is the direction of a force experienced by the conductor Q. This is in a right hand side. This is the direction of force. Now, here we find out the magnitude of that force. Now, what is the magnitude of that force? Here the force due to the current I and here the current flowing through the wire R is suppose F P, and the force due to the wire P is suppose F, sorry, here this is the F P and this force is suppose F R. Here the total force acting on the wire Q is how much? This is the net force F is equal to F R plus F P, right. So, here we get that force F is equal to F R plus F P. ठीक आहे. मग ही ॲडिशन जी असणार आहे ती थोडक्यात त्याची जी काही मॅग्निट्यूड असणार आहे टोटल फोर्सची ती असणार आहे. मग आता फोर्स कसा फाइंड केला होता आपण? वी नो दॅट द फोर्स इन बिटवीन द टू लॉन्ग पॅरलल कंडक्टर इज व्हॉट? F इज इक्वल टू μ0 I1 I2 L divided by 2 pi d. Now, what is the d here? D is the perpendicular distance between two long parallel conductor. L is the length of that conductor. Here I1 and I2 are the current flowing through that conductor, right. By using this formula, here we find out the Fr and Fp. Fr and Fp चा फॉर्म्युला जो असेल, जी व्हॅल्यू असेल ती आपल्याला या फॉर्म्युलाने कॅल्क्युलेट करायची. ठीक आहे. मग आता ती व्हॅल्यू कशा पद्धतीने कॅल्क्युलेट होईल बघा. Fr is equal to what? Fr is equal to, by using this formula, here we get μ0, current is suppose flowing through the Q wire is suppose I, then the current flowing through the wire R is suppose IR, and length of the wire Q is L divided by 2 pi d. What is d here? D is the distance between those two conductors. That means this distance is suppose d1, right. Now, what is the Fp plus? Here we get Fp is equal to μ0, current flowing through the wire Q is I, current flowing through the wire is P, suppose Ip, length of the wire Q is L divided by 2 pi d2. What is d2 here? d2 is the distance between the wire P and Q. ठीक. Now, what is the given here? We know that current I flowing through the wire Q is 10 ampere. Now, current flowing through the wire R is IR is 20 ampere. Similarly, length of the conductor is how much? This is the 10 centimeter given in MCQ. Now, what is the D1? D1 is also given in diagram 2 centimeter. Here we get 2 into 10 raised to minus 2 meter. Now, next, what is the current I? This current I is 10 ampere. IP is the current flowing through the wire P, that is 30 ampere. Now, length is same again. Now, what is D2? D2 is the distance between these two conductor. Now, by putting all this given, we get the answer is C, that means 2.6 into 10 raised to minus 4 Newton, and that force is towards the right.